Hello, friends and scholars. You are welcome to JoeNewton Online Physics and Maths. Of course, in this class, we are learning physics. And we have a challenging question on the board that has to do with one of the complex topics or difficult topics students run away from in exams. That is radioactivity, nuclear physics, or modern atomic physics. Good. The question has to do with radioactive decay and half-lives calculation. Then it says a radioactive isotope has an initial activity of 120 becquerel. Okay? 6 days later, its activity is 15 becquerel. That's the unit of that radioactive decay is becquerel. Okay? Calculate its half-life. Now, how do we go about this? The first thing we are going to do is we think of the relationship between the initial amount of the radioactive material, then the amount left undecayed, then the period within which the activity took place, that is the period time, then the number of half-lives that passed within that period of activity. Then when we now get the relationship between them, the formula, we're able to navigate and solve this question successfully. Okay? Then, now, the formula is simple. The formula is this. We have that 1 over 2 raised to the power of n. 1 over 2 raised to the power of n of A is equal to, of A naught is equal to A. Now, where n is the number of half-lives, that pass within the activity, that decay activity of that radioactive isotope. Then A naught is the initial amount of that radioactive element. Sometimes the question might come in mass. The question might come in grams, that's the mass. Then this A, we distinguish this with A naught. This A is the amount left undecayed in that question. Okay? Then we can now continue. Where T is equal to time or period of the decay. Okay, we continue. Now from our question now, we say that a radioactive isotope has an initial activity of 120 becquerel. So the initial amount of that radioactive activity is 120 becquerel. So we have that our A naught, so let's bring that. Our A naught is equal to 120 becquerel. Then we say that 6 days later, its activity is 15 becquerel. So which means our A is equal to 15 becquerel. Then we are given 6. 6 is the time. 6 is the time. Then we have that our T is equal to 6. Then we have to find N first. That is the number of half-lives that pass within the activities of that radioactive isotope. So we have to find N first. When we find that number of half-lives, letter N, that's symbolized with N conventionally, we will now be able to find the half-life of that radioactive element. There are two different things. Half-lives that passed within the period of time of the activity. Then we have the half-lives, plural, the times, the half-lives of the decay. Then, of course, every radioactive element or isotope or material has its half-life of decay and also has its decay constant. These are concepts you should be familiar with in treating nuclear or atomic physics. Okay? There, so N is the number of half-lives. You see it? So with this, we can now continue our work successfully. So substituting now, we will now have that 1 over 2 raised to power of n times of means times 120 is equal to a 15. This is what we have now. Okay, then that will give us, we continue, we have here 1 over 2 raised to power of n, then is equal to, take this one to this side, become division. Of course, you know that. When we take this 120 over here, become division. Want to take this 120 over here, is equal to 15 over 120. You see what we did? This 120 is multiplying 1 over 2 raised to power of n. So when it goes over here, it becomes what? Division. Good. Okay, so we have this fraction now as equivalent fraction. Then that will give us, be mindful of what I did here. This is not 2n, so that you don't go and say 2 divide 120. Avoid that error. This is not 2n. There are 2 different. This is 2 raised to power of n. So be mindful. Had it is 2n, then you can now say divide. So be mindful of these terms in algebra. Okay, so we have here, we still have 1 over 2 raised to power of n is equal to, we reduce this to lowest term. I think there is a factor here that can divide them. Yeah, there's a factor here. Let's take it gradually, small, so you understand. If I have 15 over 120, let's go with 5. 5 divide 15. Or let's start with 3. 3 divide 15 is 5. 3 divide 12 will give you 4. You put the 0, that is 40. You see what I did? 5 divide itself will give you 1. 5 divide 40 will give you 8. Remember, when you are dividing a fraction or reducing to lowest term, it is a must by rule that you must use common factor to divide both the numerator and denominator. Do not be tempted or make the mistake of using a different factor to divide the numerator and a different factor or number to divide the denominator. No, you use common factor to divide up and down. That is the rule. Okay, so we have this. So we have 1 over 8 here. So this has become 1 over 8. I want to get here. So 1 over 2 raised to the power of n is equal to 1 over 8. That's what we have here. Now, this is 2 raised to the power of n. So we are going to treat this base. What will be 2? So we want to break this down into base of 2 and power of a number. So what number will 2 be raised to the power of to give us 8? That's what we're going to think of. So the question now is, for this to be equivalent in expression, 2 raised to the power of what will give us 8? Let us try it and know. 2 times 2 is 4. 4 times 2 is equal to 8, which means that 2 raised to the power of 3, because this is 1, 2, 3, will give us 8. Good. This is how to evaluate it. Okay. Therefore, by equivalence, we have that 1 over 2 raised to the power of n is equal to 1 over 2 raised to the power of 3. Let me write it clearly. 1 over 2 raised to the power of 3. So by equivalent, these two are equivalent. So very simple. Remember, we are looking for our n, the number of half-life, which is this letter n. Now, since these are equivalent, 1 versus 1 off. So which means here is 2, here is 2. Therefore, we have that 2 raised to the power of n is equal to 2 raised to the power of 3, right? In that case, this versus this, we left that n is equal to what? 3. I mean, this is equivalent to this, is not division. This is equivalent to this. That's what you mean. So n is equal to 3. Okay? So our n is equal to 3. Now we have found our n, which is the number of half-lives. But the question asks us to find the half-life itself. This is where some students make mistake in external exams, because this is a question, this is a critical question taken from past questions. You see this in JAMB, you see this in international Cambridge examination. So be mindful of this the question. So we are asked to find the half-life itself, not the number of half-lives in the activity. So now we do what? We find the number of half-life. Let me use here now. So that becomes that here, therefore here, we have that our, from the question, the half-life, we normally use T half for half-life. T half will now be equal to this T divided by N will give you the half-life. So the half-life will be that T, let me use the symbol first before substitution, equals to T over N, number of what? Half-lives in the activity, which is equal to 6 over 3, which is equal to 2. So we have 2, and they give us in the question in days. If it is in minutes, use minutes. If it is in hours, use hours. If it is in years, use years. But it is in days. So you refer your answer to the unit in the question. So 2 days. That is the answer. So the half-life is 2 days. So we have found out the half-life of that radioactive element, T half. The T half of that radioactive isotope is 2 days. Simple. That's our answer. Very good. So I believe with this, you can solve similar questions when you see them in any kind of examination. Thank you for paying attention to this class. Do not forget to share, like, and share this video so that all other scientists or science scholars will also enjoy and learn with us. Then if you need private tutorial, online lessons on physics and mathematics for your examination preparations and advanced knowledge at all levels, just chat me on my WhatsApp or drop message for me in the comment box or my inbox. Then do not forget to keep following me on this page for more tutorial videos and fun lessons on physics and mathematics. Then I urge you to subscribe to my YouTube channel at JoeNewton Online Physics and Maths, and also share that for others to learn. Together, like I always say, we can end science and math phobia among students. Thank you so much.